Well, next, I want to bring up Dr. Gaurav Pandey. He's going to be talking to us today about his use case, which is actually using our digital twin in its state today. Thank you.
Thanks, Darren. So, yeah, while the slides are coming up, my name is Gaurav. I'm an associate professor in Texas A&M University. I recently joined academia. Before that, I was working at Ford with Greg Stevens, actually, for a long time, and have been the user of Mcity from day one, actually. We have used Mcity quite a lot, and I can very confidently say that Mcity has a very big role that it has played in advancement of the autonomous vehicle technology, like worldwide, right? I mean, all the OEMs have been able to use Mcity. That's so fantastic for the development of the technology. And I wish that Mcity was there when I was doing my PhD decades ago, because I remember, I'll share a small anecdote. When we were doing the research, one of the biggest challenge that we had was how to test. We could not find any place to test. What we ended up doing was we used to block off the yellow parking lot, if people know that one, the one right in front of the Ford Robotics building. So we used to block that off. And you know what? I mean, it's full most of the time. So the only time we could test was during the nights or on the weekends. And we had to have 2 graduate students with walkie-talkies at each entrance to guard the parking lot so that no one else can enter. So it was a huge kind of I mean, it was a big challenge to really just test an algorithm. So I still remember the days where my colleagues will call, hey, I want to test a planner. Can you come? I said, why? We need one person to guard the entrance of the parking lot. So we did all of that. And thanks to Mcity, the students don't have to go through that. And I think it has been really helpful. And with the advancement of Mcity 2.0 today, I can sit in Texas A&M and still can test my algorithms there. So again, thanks to NSF for supporting that. And thanks to Henry for the vision that he brought to this. So with that, let me dive into the actual presentation. So today I'll be talking about the use case, which is how do we do perception for AVs and how do we leverage Mcity 2.0 to do that development. So this is the overview of the presentation. Here is the research team. So myself, Gaurav Pandey, I'm an associate professor in Texas A&M. This is work in collaboration with Dr. Reza Langari, who's a professor in mechanical engineering, and the PhD student, Pardesh Tagavi. She has been working on this from the development of the network standpoint. So traditionally, any autonomous vehicles require these very extensive 3D maps of the environment, which are typically created by manually driving through the environment using these mapping vehicles, which consist of multiple LiDARs and very high-end inertial navigation systems, which are used to stitch the 3D point cloud together to create these nice 3D point clouds of the environment. These are then manually annotated to mark out the lane lines, trees, the facades of the buildings, trees. And then when you go back to the same environment with the same sensor, you can localize yourselves within that environment. And then you can match the things that you had seen in the map with what you're seeing currently and identify what are the dynamic obstacles. And based on that, you plan your route from point A to point B. So this is kind of the traditional way that Waymo or any other self-driving company does the autonomous navigation today. But again, as you see, there is a big challenge with this is creating that map. It's pretty much like creating a digital twin of the environment, and it is very expensive and time-consuming and manual process. So the research that we are trying to target in this work here is, can we perform mapless navigation just with monocular camera? So one of the biggest challenges with monocular camera is that you don't get the depth. But now with the advancements of AI, you can actually train neural networks, which can, from RGB image alone, give you an estimate of the depth of the environment. So here we have basically developed a network which can take in an RGB image and give you an estimate of the depth, as well as the semantic label for each point in that image. Once you have both these information, you can create a rich 3D semantic label map of the environment from that. Again, for training, we do need ground truth depth information. which either can come from like a stereo camera, or in this case, we have mostly been using the Mcity digital twin. So it gives us the depth and the semantic segmentation label automatically. So we use that to train the network and develop, and basically from a single RGB image, you can create a rich 3D semantically labeled information about the environment. So that kind of helps you not depend on the map that you'll have to create a priori. So the architecture that we have developed is called SwinMTL. It's a shared architecture for simultaneous depth and estimation and semantic segmentation from monocular camera images. It relies on a Swin transformer backbone, and then we kind of have a multi-layer perceptron at the end of this to generate the depth as well as the semantic segmentation. And we train this network, and we have used a lot of Mcity digital twin data to train it. I mean, it's still in the early ages of training, and we hope that we'll get much better accuracy as we train it with more and more data. So the second research question that we also want to answer, and I think this has been discussed multiple times in the talks today, about can we offload some of this perception to cloud? So do we need to have these very high-end GPUs on the vehicle to run this perception? Or we can just upload the camera data, run the perception on the cloud, send the information back to the vehicle, and then use that for autonomous navigation. So that's another research question we are also interested in looking at as part of this research. So how Mcity is benefiting us from this? The first is the mixed reality simulation. So Mcity can provide us with a huge amount of simulated data, which we can use to train our algorithm. And then with now the partnership that is announced today with NVIDIA, we are hoping to get more realistic simulated data, which we can use to make our sensors better or make our algorithms better. And apart from that, this mixed reality simulation, what offers us is that the rarity of events, right? So the biggest challenge with using real-world data is that you don't really see those very rare events that are really important for the algorithm to learn. And this mixed reality simulation will allow us to basically see those data beforehand and train the networks for those. The second thing is the remote operations of test vehicle. So again, to answer the second research question, we will leverage a lot of this to see how much amount of data do we need to get from the vehicle? What is the right amount of data that we need to send to the vehicle? What are the latencies involved? How much can we how much latency can we afford, and so on. So there are lots of things, and I'm very excited about the research possibilities that Mcity 2.0 has kind of opened the doors for us. With that, I'll talk about the demonstration. So today what you will see is basically the simulation running on the Mcity digital twin. So there is a pre-planned route for the vehicle in the digital twin. It will go through that. And then the TerraSim and Carla will generate the virtual camera images. Those camera images are actually fed into a desktop, which is sitting in Texas A&M, which is running the perception algorithm. And then the output is sent back to us just for visualization for now. Eventually, we will connect it to the vehicle in the loop testing, where the vehicle will be hopefully controlled by that perception output. So with that, next steps. Again, the next steps would be we want to develop this perception network further with Mcity data engine, and then leverage the simulation data from realistic sensor models from NVIDIA, and also validating the perception on cloud via closed-loop testing. So with that, I can go to the demo. This is the remote desktop where I'll log in. This is sitting in Tamu. And right now, we are getting the feed from Mcity. So on the left, you can see this is the RGB image that the virtual Carla environment send us. This top-down Mcity map is just for visualization purposes. We don't use it right now. The main thing that we use is this RGB image. And then, let me minimize this. When I run, so the vehicle is moving. I've started my algorithm. So now you can see, let me minimize this? Sorry, the zoom is making it slow, but what you see on the right is, on the bottom is the depth image that is being generated by the network. On the top is the corresponding semantic segmentation map that we have learned. The yellow dots are basically the 3D point of the center of the vehicle that we are detecting. So once you know the depth and you know that this pixel corresponds to vehicle, you can actually know the 3D point cloud or 3D point of the center of the vehicle. So this is the current state of the algorithm right now. We are hoping that we will be able to train it even further. With more data, the accuracy will increase further, and we should be able to eventually control the vehicle in closed loop using this perception on the cloud. So I can take any questions while this is running. Yes?
So maybe I'm mistaken, but I was under the impression that like RGBD cameras are becoming more accessible and more affordable and fairly commonplace. Are you at risk of doing the D part and then just instead one piece of hardware we're replacing?
That's a good question. But so RGBD cameras are very common in indoor applications, but in outdoor application, we still rely on stereo for creating that depth. And that process still is a little bit computationally expensive. But yeah, you're right. We can eventually get it around using the hardware. But we just want to push the envelope of the research and see if we can do as good as that 2 cameras with just 1 camera or not. And Mcity is helping with that kind of research. So, yeah.
Yeah, and just one more point on that. The one sensor modality that is standard on every new vehicle today is a forward-looking mono camera, right?
Yes.
So that's the most pervasive standard piece of sensor hardware in the market. So if you take, an algorithm like Gaurav's here, it could be run on what is right now the most pervasive sensor hardware in the market.
Yep. Thanks for that. Yeah.
Great talk, thank you. The quick question is, do you transmit video streams between?
Yes, so we are getting this RGB camera stream from Mcity. And then right now we are also sending the whole semantic segmentation and the depth map. But the part of the second research question is, do we need to send all of it, or do we just send the points and that's enough for navigation? I think we want to test all of that. Yes.
Thank you. Yeah.